Eyes looking up at me, we might as well go ahead and move on together. So please make sure at the top of your paper you have headed it with your name, your date, all that good stuff that always goes on our papers, and then chapter 3 class revisions. And you can put like chapter 3 mastery or chapter 3 test or something if you want to. I believe I need to reorient this really quickly. Who now thinks, with my feedback, like who's found a mistake? You're like, man, I shouldn't have done that, or like, I know better, or like just looking at it again with a little bit of feedback. Anybody? Yeah, you're like, man, gosh, should not have done that. Those brain fart moments happens. So we're going to go through some of these quicker. We want to have some good time for number 8. You are not writing anything on your test. So here's what I need from you right now. And some of you last time did not take advantage of this and you made more work for yourself. When we go from progressing to mastery, and you're going to give yourself your grade unless I disagree, when we go from progressing to mastery, we're going to make up new problems of a similar type that we have to understand, and it has to actually be a challenge. So we're going to keep ratcheting up what we're expecting out of you guys. So we're learning about that whole mastery thing, right? What does it mean to master? At the end of today's class, and I'm going to be very specific about making sure I give you guys time, you are going to write a paragraph for me on what grade you think you would give yourself and why. So you can't just put a P or an M or whatever. You need to be able to say, I feel like I would have mastery on this because yada, yada, yada. You have to explain. Or I feel like progressing because I need to practice this. Or I goofed up this and could benefit from going over it again. Or I need to come talk with you because I still don't understand whatever. So we're going to take at least 5 minutes at the end of class to do that. So that's what's going to go on your paper, as well as we go. If you had any mistakes on your test, you need to write the correct version on your blank piece of paper. We're not writing on the test. And even if you got it right, it'll help your brain to do it again. So really, nobody should be off task or anything else. Even if you got it right, you can be writing these things if you need something to do. So really quickly, we're going to go through this. And I had a few like favorites as I went through here and looked at your tests. One of my favorites, and I forget who it was, looked at this like pizza. All right, we talk a lot about pizza. So they said, if we look at this as Mr. Scherg bought us a pizza, but when he brought it to Mr. Smith and I, he had already eaten a fourth. So Mr. Scherg ate a fourth. So we have 3/4 left. And they said, now Mr. Scherg and I, or sorry, Mr. Smith and I, was this somebody in this class or was it the other class? Anyone remember if this was you? Okay. So they said, Mr. Smith and I can't split 3 pieces. So because we cannot split the 3/4 that we have right now, we decide to cut everything, each piece, in half. And cutting those pieces in half means dividing by 2. So we take the pizza that we have, cut it in half, which is dividing by 2, which will double, they went on to show, the amount of pieces we actually have. And you end up with, now wait, 6/4? That doesn't make any sense. So we had to get to the point where we get 3/8. And it said we can't just say invert and multiply. So in the work that we're showing, they show us, not highlighter, and everybody please write, even if you had it right the first time, they show us 3/4 divided by 2 equals 3/8. Is the 3/8 everything that's shaded? So if we think about the pizza situation, what is the 3/8? Patrick? It's like my amount of pizza that I get, right? Think about this, like you and whoever, we'll use Mr. Smith here, are splitting what's left of the pizza. What's, I might just go quickly. Anyone remember how we use the giant 1 here to help with this division? What if I set my division, and please do this on your paper because very few people did this. What if I make it 3/4 divided by 2 over 1? Because this is just 2 over 1, right? I can divide by 1 and it doesn't change anything. Guys, I'm going to be looking for this stuff on this paper that you're turning in. These are skills we need some more practice on. A lot of us weren't using these skills that we want to. Right now, I've made a giant fraction, right? It's got fractions inside of the fraction. This is called a complex fraction. It's complicated. Complex, complicated. This is my numerator. This is my denominator. What denominator does nothing? Doesn't change a thing. 1, right? A denominator of 1 doesn't change anything. How do I turn my denominator of 2 into 1? What can I multiply by to turn 2 into 1? Alex? A half. So, in the denominator, please show this on your paper, we multiply by a half. Which means in the numerator, we multiply by a half. This is our giant 1. Straight across 4 times. We get 3 over 8 all over 2 over 2. Which is just 3/8 over 1. You cannot just say, oh, we keep change flip, or we invert multiply, or we turn to... You can't just say what we do. You have to say why. This is one way to talk about it, where we use the giant 1. We want to get comfortable saying anytime I have a denominator, if I turn it into 1, it no longer matters. And my answer is just 3/8. Because that's my pizza that I got. Right? Not what is shaded shown, but if we took the 3/4 and split it, what's half of the 3/4? Any questions on this remaining? Everybody have this on their paper. It's good. It's explained like it. Your math explains it. Ooh, whoa. Why are we jumping so many pages? So then we had this diagram, and for the sake that some of us are visually challenged like myself, I'm going to draw this out again. So I'm going to do something different. I'm going to say we have x and x and x and 2. And then I'm going to change colors here. Say we have 2 and x and 8. Right, because we know that those tightropes are the same distance. Can anyone explain to me how you thought through this? We'll write the equation in a minute, but how you thought through solving this to figure out what x is. Now, I will tell you, one thing worked here that I really wish didn't work. If you lined up these values, you could visually figure out that x was 4. You could actually visually do it. I wish that didn't work because that doesn't push the math skills. So not the visual way of just saying, oh, 2 is half of x. That is not what I'm looking for. How did you reason through it? Not Alex or Patrick, because we already called on him. Grant?
I noticed it as basically the top problem was sacrificing 2 x's for an 8.
Ah, so you're saying the top and the bottom have the same thing, like a 2 and a 2, an x and an x, and then we have these x's equal that 8. There's actually some people that seem like they're trying to avoid looking up here. Can I please have your eyes? Because we're moving some things around and it's worth seeing. I did not change what we had up here. I just moved stuff around. So now Grant said, well, if the 2's are lined up, these x's are lined up, these 2 x's equal 8. Does that make sense to us? Take a moment, show that on your paper. How, like, you could just copy the tightrope like this, but by moving some things around, it's a whole lot easier to work with. Or if you were looking here, we could say, okay, 2 and 2, x and x, and then what's left over has to equal what's left over. Now, it asks us to write an equation, so I'll give you a second, but then we're going to actually write the math equation. If I just try to write that the one tightrope equals the other tightrope, I would be saying 2 plus x, and you want to write this on your paper, please, plus x equals 2 plus x plus 8. Now I changed the order that the values come up in. Am I allowed to do that? All right, I'll go ahead and say I am allowed to do that for a piece of candy. See who's awake on this Monday morning. What property allows me to move the things I'm adding? Marvin, is that a hand or no? You were the first one to like go halfway there. Ella, you were the next one I saw. Say it louder. The commutative property says when all I'm doing is adding, order doesn't matter. I just move stuff around however I want. So now what we do, and what I need you to show on your paper, we took away, or like looking at, we said, well, these are the same, get rid of them. These are the same, get rid of them. So we took away a 2 and we took away an x. We took away a 2 and we took away an x. So go ahead and show that. What we're then left with is x, that's kind of small, x plus x equals 8, which we could actually say 2 x's is 8. Because here's what's problematic now. I cannot take away an x. A lot of people here would say, well, take away an x, and you can figure out what 8 is, or what x is. But I can't take away an x from my 8. What can I do to my 8? Ella?
So if there's 2 x's, what can I divide by 2?
I can divide by 2 because we know 2 times something equals 8. So please show on your paper, this is multiplication. We should know that a number right up against a variable is multiplication. But if I divide by 2, I do it on both sides, and we get that x equals 4. Questions? So if you go to make a problem like that on your own, all you're doing is setting up some numbers with x's and some numbers with x's, take away what you can that's common, then if you have multiple x's left over, divide to get down to only 1. Questions? Okay, now Zevel gives a challenge, and a lot of us had a bit of struggle with this. So Zevel's like, man, 3/7, terminating, repeating, Some of you guys trusted your calculator. Don't trust the calculator blindly. Zevel says it doesn't work. Now, one of the reasons I love math is there's no situation when it doesn't work. So please write on that clean paper 3/7. What Zevel comes to you asking about. You didn't share? I'm going to have to start putting like an import tax. If you bring snacks into my room, you got to pay an import tax.
Actually, the pretzels look like $20.
You did. I do. No, like food. I don't care about money. I care about food. So, who can tell me what this is? How we read this? How we look at this? What is it? Patrick?
3/7.
What? Okay, so give me more.
Say if you're trying to figure out the decimal of it, you just divide the numerator by the denominator.
Okay, so another way you can say it is 3 divided by 7. Right, so we've got 3/7 or 3 divided by 7. If I think about this, my pizza dude is crazy, and he cut my pizza 2, 3, 4, 5, 6, 7. He cut my pizza into 7 slices, which would be really hard to cut, which is why they wouldn't do that. And I have 3 of them. Right, so Zevel's asking you, what is this decimal? If you got a number bigger than 1, that doesn't make sense. You did your division backwards. This is 3/7, which if I go into long division form, numerator goes inside. Denominator goes outside. It's knocking on the door. Numerator starts with an N, goes inside. All right, so I'm going to leave that picture up there. So Patrick said if I divide it, I get, what do you say, a repeating?
Yeah.
Now in your calculator, it doesn't show repeating. Don't trust your calculator. It only has so much space on the screen. The last number is sometimes rounded. It's a lie. So be careful. If I do this division, please show this on your paper. We're going to show this long division together. Even if you got this right, go ahead and write it on your paper because it's fun. Please do not think that you're doing the earth a favor by writing as small as possible. Give your numbers a line. Like a line of height. Don't, like, come on, let yourself see the numbers. This should take up a line right now. How many times does 7 fit into 3? None. And we should know that just because 3 out of 7 will be a number less than 1. So we now look at 30. How many times does 7 fit into 30? Anybody,
4.
just shout it out. 4. That gives me 28 that I take away. Now, you can use a calculator on this, but when you have to show why something happens, you can't just write it's repeating because my calculator said so. Right? That doesn't work. We drop down to 0. Now we're looking at 20. How many times does 7 fit into 20? 2. Guys, I'm going to be looking for this on everybody's paper. Even if you got it right, we're all doing this together. How many times does 7 fit into 60?
8.
What is that?
8. Oh, wait.
56. I always thought that was fun because 8 times 7 is 5, 6. I'm a weirdo. How many times does 7 fit into 40? 7, 14, 20, 28, 35. So that's 5. How many times does 7 fit into 50? 7, 14, 21, 28, 35, 42, 49. That's 7. Guys, if you have to count on your fingers, it's okay. I still do it. No one's going to come arrest you. If you're in the supermarket doing math in your head and you're using your fingers, the other people aren't even doing math in their head. So it's okay. Drop a 0 for 10. How many 7s fit into 10? 1. That one's easy. And now is where we see the magic. We drop a 0 and we have 30. Why is this 30 like an alarm in our head? Marvin. Because there's already a 30 in my long division. If I compute this, and I say how many 7s will fit into there, I get a 4, which there's already a 4. And if I go again, I'll get a 2. And if I go again, I'll get an 8. And we see that we have started repeating. When we get, and I'm sorry that I did not squeeze this onto one screen, but when we get a number as the remainder that we already had as the remainder, we've entered an infinite loop. And this is where if you're unintelligent, you keep going and you spend days and days and days and days and days and days and days doing long division. That gets you nowhere because you'll get the same numbers over and over. So smart people eventually said, hey, I don't want to work anymore, right? We all reached that point, like, you don't want to work today, which is, we're back from break. I didn't want to like do a new lesson or anything, so I wanted to give you an easy day. Stop working. Work smarter, not harder. You see the 30 that you already had, stop working. And I had some people keep going to show a few more, which is sweet. But any questions on this? Understanding why repetition happens is weird. So like if you have questions, please ask. Like this is like odd. Not odd like numbers. But. Now here's the other like thing that you can just put in your memory. Division by 7 always repeats. Now you can't just say that, like you'd have to show why, but division by 7, unless it's like 14 divided by 7 or something like that, but division by 7 always repeats. Questions? It's a prime number. It's weird. Why explain, or sorry, not explain, be clear and complete. Some people just wrote like this again, but using an equal sign. Guys, when it says why, or it says explain, or anything like that, you're not going to get away with the minimum. We need to know why you're thinking this. The best way that you could have done this, and if you had any mistakes or if you just want to do it again, the best thing I saw out of people was very, very simple. They showed -6. They said, well, this is remove 2 negatives. So they showed they removed them. We don't know where that arrow goes, but it goes somewhere. And it's elsewhere, right? We removed them. And then they wrote left with 4. That's it. That's all you had to do. We did this in class, right? We modeled with those tiles, which we need a new name. But we modeled with these, and we started with 6 negatives. Subtraction is takeaway. We take away 2 of the negatives. We are left with only 4. Guys, they gave you the answer. You can't just put the answer and expect. We gave it to you. You got to give the explanation. Other explanations worked as well. But even some, like, look at your paper, and if you said because minus a negative is plus a positive, that's not really a good explanation. That is the rule, but that's not really a good explanation. Some of you kind of quoted the posters up there, because when there's like minus negative, it cancels out. Now the other thing that some people showed that isn't really an explanation, but some people showed it like this. They said the -6 minus -2. They showed this like we did in class. Then they said -6 plus 2, but still that's not really a good explanation, because if I have 6 negative tiles and then I add 2 positives, then it cancels and it makes zeros, and there would actually be more to explain. Monica?
What if you use a number?
That can work too, except it depends how you showed it. Because to show subtraction, we go left, but then to show subtraction of negative, it gets kind of hairy. So be careful. Like, you can, but it's all about how you show it. The tile way would be easiest, just because we can say we have this, took this away, what do we have remaining? I got to speed up a little bit because I don't even think we're going to have time to get to number 8. Why does negative 3 times negative 2 equal positive 6? Because one of these can be looked at. What's another word for negative? Opposite. So please write this on your paper. Opposite of negative. That's all you would have needed to write. Opposite of negative. And then you could say is positive. That would be dandy. Of is multiplication. Opposite of negative. Then, obviously, you got to think about the numbers. But the opposite of a negative is a positive. Questions? Is 0.41 less than 1 or more than 1? Yeah, this is not a trick question, right? If I have a pizza, and a pizza has 8 slices, right? If I have less than a pizza, could I have 12 slices? Could I have 80 slices? If I have less than a pizza? No, that doesn't make sense. When we multiply by less than 1, my number has to get smaller. Did my number get smaller? From 6, even forgetting about the decimals, from 6 to 24 is much bigger. This is wrong. We can identify pretty quickly that this is wrong. Jasmine's got a mistake, because less than 1, if we multiply by less than 1, we get smaller. They did not. Anyone know what their mistake was? It's a pretty small one, actually. Allie? They put the decimal in the wrong place. How many decimal places should there be? Like in the answer, they have 2 decimal places. Do you know how many? There should be 3. However many decimal places we start with. Sorry, my pen's writing a little bit high. But we had 2 decimal places and 1 decimal place. We will use 3 decimal places. Now that's one way that we can answer it. Another way, we could set up fractions, we could set up mixed numbers, we could do a whole lot of things. We could show the multiplication process written out. Like, there's a lot of options here, so I'm not even really going to show you. But this answer should be 2.448 using 3 decimal places. Questions? I need to give you time to write. This 9/8 is over 1, bigger than 1. So my percent is going to be bigger than 100. If you have more than 1, you have more than 100%. This is weird. We haven't done much with this yet. So this was one that was starting to kind of push you a little bit. But if I do the division, say 9 divided by 8, we get 1.125. But that's not percent. So a lot of you, I had to write on your paper, move decimal for percent form. Percent is over 100. This is over 1, right? That is just the number. To be over 100, I have to multiply by 100. The answer should have been 112.5%. I really wanted to go over 8, but to give you time, I'm going to stop here. I need you to write me a small little letter, message, whatever you want to say, note how you think you did, and some explanation of why. Do you need more practice? Did you just forget stuff that day? And this is not like please don't lie to try to save yourself work. I know what you need, right? This is my 6th year through all this stuff. So just be honest with yourself. Did you maybe not put enough effort into your homework, and that's why you had some issues? So take a few minutes. We've got about 5 minutes left.
Do you do it on the back?
Yeah, if you need to use the back of that blank sheet, that's fine. That will get stapled on top of your test. Okay, so when you come to turn this stuff in, nobody can turn it in until I tell you. So take a few minutes, write me a message.